Hey everyone, and welcome. So have you even been playing around with a really powerful AI image generator online and just kind of wondered, why is this so expensive? Or why does it sometimes take forever to get started? Well, it's a huge challenge, and today we're going to peel back the layers and look at the architecture behind cloud AI to figure out exactly what is going on.
So let's just dive right in. This is the big question we're tackling today. Why is using these amazing, super powerful AI tools in the cloud so often a slow and expensive experience? You'd think the cloud would be all about efficiency, right? Well, it turns out the answer is all about how these things were originally built.
All right, so to really appreciate the solution, we first have to get our heads around the problem. We're going to start by looking at what you might call the old way of doing things, an architecture that creates a massive dilemma for pretty much everyone involved. So the traditional way this works is with something called a dedicated GPU instance. The easiest way to think about it is that you're literally renting an entire, super powerful computer in the cloud. And the key thing is you're paying for it by the hour. This computer has one single really high-end graphics card, a GPU, and that one card has to do everything you throw at it.
This whole approach leads to what is probably the best analogy I've ever heard for it. Using one of these dedicated machines for a quick AI job, it's like renting a massive 18-wheeler semi-truck just to deliver a single pizza. I mean, yeah, the pizza gets there, but the amount of overkill and waste is it's kind of nuts when you think about it.
And this whole 18-wheeler for a pizza problem, it doesn't just create one issue. It creates a whole bunch of them. So let's break down the 4 biggest problems that come from this old-school architecture.
We're talking about 4 huge roadblocks here. The cost is just prohibitive, you get high latency, which is that annoying waiting time, there's a ton of waste, and it just doesn't scale well. Let's walk through these one by one, and you'll see why a change was so badly needed. First up, the cost. This one's a killer. Because you're billed by the hour, you have to pay for that full hour, even if your AI job only takes, say, 45 seconds. All that time the machine is just sitting there, doing nothing? Yep, you're paying for it. Our source material calls it a costly affair that will pinch your pocket, and that's putting it mildly.
Problem number 2 is all about the experience, and it's something called the cold start. I bet you felt this. Before your request can even begin, that giant dedicated computer has to wake up, boot up, and then load these massive AI models. We're talking gigabytes of data into its memory. All that time you're just drumming your fingers on the desk waiting. That's the cold start.
And third, you just have incredible, massive waste. Think about it. A complex AI job might have multiple steps. The first step, generating the image, might need that super powerful, expensive GPU, the 18-wheeler. But a later step, like just making the image a little bigger, a much cheaper GPU, like a bicycle, could handle that just fine. But with this model, you're stuck using the 18-wheeler for everything.
Okay, so we've got a system that's expensive, it's slow to start, and it's super wasteful. There has to be a better way, right? Well, of course there is. So let's dive into the solution, a much, much smarter architecture. The answer is something called a serverless microservice architecture. Now, I know that sounds like a mouthful, but the idea behind it is actually really beautiful and simple. Instead of one giant do-it-all machine, imagine you have a whole team of specialized experts. Your big complex job gets broken down into tiny little tasks, and each task gets sent to the perfect expert for that specific job. And here's the best part. They're always ready to go, and you only pay for the exact number of seconds each one works.
I mean, what we're talking about here is a complete shift in how you think about the problem. We're going from paying by the hour to paying by the second. We're moving from one giant monolithic machine to a flexible team of specialists. We're basically trading in massive inefficiency for total optimization.
Okay, so that sounds fantastic in theory, right? But how does this whole thing work in the real world? Let's pull back the curtain and really look at the nuts and bolts of how this smarter system operates. So instead of having just one type of computer, the system maintains these different pools of GPUs. Think of it like a workshop. You've got Pool A with all the heavy-duty power tools, the expensive A100s, for the big jobs like creating an image from scratch. But then you have Pool C and D with cheaper, more efficient tools that are absolutely perfect for smaller follow-up tasks like upscaling or restoring faces. It's all about using the right tool for the right job.
So who's the genius conductor of this whole orchestra? That's a piece of software called the orchestrator. You can think of it as the brain of the entire operation. When your request comes in, it looks at it, and it intelligently breaks it down into all the little individual steps. Then it acts like a super smart air traffic controller, sending each little task to the absolute best GPU pool for that job. And then, once all the pieces are done, It puts them all back together and sends you the finished product.
Okay, so now we get it. We have the old 18-wheeler model, and we have the new smart team of experts model. So let's put them head-to-head and see what the real difference is. And I gotta tell you, the results are pretty stunning.
I mean, come on, look at this. It's a total knockout. The serverless model just wins, hands down, on every single metric. When it comes to cost, you're paying per second of work, not for an idle hour. Performance? It's basically instant, because those experts are always warmed up and ready to go. No more cold starts. Efficiency is through the roof, because you're using the exact right hardware. And scalability is amazing, because each little pool of experts can scale up or down all by itself to handle demand. It's just a completely different ballgame.
And if you need to see this in dollars and cents, check out this simulation. For a pretty typical 45-second creative job, the old dedicated model is going to cost you $4. Why? Because you had to rent it for the whole hour. The new serverless model, 5 cents. No, that is not a typo. $4 versus 5 cents.
Let me put that another way. For these short, bursty, creative jobs that most people are doing with AI, this new architecture isn't just a bit cheaper. It is 80 times cheaper. That is just a transformative, mind-boggling difference.
So what does this all mean for the future of AI? And this isn't just some clever little technical improvement. This really is a fundamental shift in how we can build, provide, and access these incredibly powerful tools.
So let's just recap the huge takeaways here. This serverless approach gets rid of all that wasted money on idle GPUs. It kills those frustrating cold start delays. It perfectly matches the right tool to the right task. And really, the most important thing of all, it makes advanced AI so much more affordable and accessible to so many more people.
And that really brings us to the final big question. When you tear down those barriers, the punishing costs, and the frustrating delays of the old way, are we finally opening the floodgates for creativity? Is this type of smart architecture the key to finally putting these amazing tools into the hands of every artist, every designer, every creator out there? It's a pretty exciting thing to think about. Thanks for tuning in.